Initial value here, and I need a common ratio, right? What's my laser beam's initial value? How many milliwatts, Colby? 5, right? So A is equal to 5. So check this out. I'm going to have P of n is equal to 5 times something to the power of n. Now this is where we have to use our brains a little bit more. Okay, the initial value is pretty easy to extract from the problem, but now we've got to put our thinking caps on to figure out what my B is. Okay? Because you see that 1% and you go, oh, 0.01. But like we saw in the warm-up, that's not the case, right? Is it going to be 1.01? Give me a thumbs up if you think it's going to be 1.01. Okay, if it's not going to be that, what's it going to be? Negative 1.01? That's a good thought. I like that. Anthony? Beautiful. Exactly right. Is it gaining 1% of its power? No, it's losing 1% of its power. So after reflecting off 1 mirror, the power will be 99% of what it originally was. Great job. I totally understand, Mohammed, you think in negative 1.01. That's what I initially would have thought. But if I'm losing 1% of my power off 1 mirror, well, now I'm at 99% power. Does that make sense? So my B value is 0.99. Like I said, when that B in the middle is less than 1, we have a decay function. It's getting smaller, decreasing. If I'm losing power every time it reflects, my amount of power should be decreasing exponentially as we go along. Okay? So let's say, let's ask ourselves another question. Let's say, what's the power after reflecting off 10 mirrors? What's the total power of my laser beam now after reflecting off of 10 mirrors? And you may think, oh, well, I'm losing 10%, right? If it's 10 mirrors, 1% per mirror, 10 mirrors. But this is what makes exponential functions so weird. Okay, let's see. What are we actually going to do if we want to solve this? We're going to take that 10 and we're going to put it where? In place of what? N. So P of 10 is equal to 5 times 0.99 to the power of 10. Well, what's 0.99 raised to the 10th power? 0.904, we'll call it. 0.904. No, because it's not a repeating decimal. It's just a bunch of crazy random numbers. We only put that line on top when it's the same pattern, like 55555. Great question. Okay. Everybody with me so far? Yeah. Okay. Now we just do 5 times what? 0.904. 4.52. What are my units? Milliwatts. Whatever that means. So if my initial power is 5, right, and I lose 1%, and I do 5 times 0.99, now my power is 4.95. Okay? So for the first round, 1% would be 0.05 milliwatts, right? But then if I take this and multiply it by 0.99, okay, now it's slightly less. You see what I mean? Because if I take the same percentage of a smaller number, I have a smaller result. I don't know if that makes sense. This is one of those things where, like, the more you do it, the more sense it's actually going to make. I feel like I might be over-explaining it. But quick show of thumbs. Is this making sense? Thumbs up. Yeah, it seems all right. Thumbs sideways. I don't know. Maybe kind of. Thumbs down makes no sense at all. Okay. Well, let's just jump right in and see how it goes. All right, go ahead and sign on your